For Chapter 1.3, we're going to be talking about the Introduction to Experimental Design. Take a second to read pages 22 through 23. If we want to plan a statistical study and gather data, there are some essential components of obtaining reliable information. There's usually a great deal of research and planning that is involved. So, planning a statistical study. First, you want to identify the individuals or objects of interest. Secondly, specify the variables as well as the protocols for taking measurements or making observations. Third, determine if you will use an entire population or a representative sample. If using a sample, you want to decide on your sampling method. Then you're going to collect data. And then you're going to use appropriate descriptive statistic methods and make decisions using appropriate inferential statistic methods. Lastly, you're going to note any concerns you might have about your data collection methods and list recommendations for future studies. Things you want to think about. Are you going to use an entire population or a sample? If we use data from the entire population, we have something called a census. If we use data from only part of the population, we have a sample. So looking at this picture here, the census is an entire population. And if we only take a portion of the entire population, that would be our sample. Take a second and read pages 23 through 26. When gathering data for a statistical study, we want to distinguish between observational studies and experiments. Here's an example of an experiment. In 1778, Captain James Cook landed in what we now call the Hawaiian Islands. He gave the islanders a present of several goats, and over the years, these animals multiplied into wild herds totaling several thousand. They eat almost anything, including the famous silver sword plant, which was once unique to Hawaii. At one time, the silver sword grew abundantly on the island of Maui, but each year there seemed to be fewer and fewer plants. Here is a photo of the silver sword plant. Biologists suspected that the goats were partially responsible for the decline in the number of plants and conducted a statistical study that verified their theory. All right, so to test their theory, the park biologists set up stations in remote areas of Haleakala. At each station, 2 plots of land similar in soil conditions, climate, and plant count were selected. One plot was fenced to keep out the goats, while the other was not. At regular intervals, a plant count was made in each plot. So this study involved an experiment because a treatment, the fence, was imposed on the plot. So the experiment involved 2 plots at each station. The plot that was not fenced represented the control plot. This was the plot which a treatment was specifically not imposed, although the plot was similar to the fence plot in every other way. In medical experiments, the placebo effect is the improvement or change that is the result of patients just believing in the treatment, whether or not the treatment itself is effective. To account for the placebo effect, patients are divided into 2 groups: the control group and the experimental group. One group receives the prescribed treatment. The other group, called the control group, receives a dummy or placebo treatment that is disguised to look like the real treatment. Finally, after the treatment cycle, the medical condition of the patients in the treatment group is compared to that of the patients in the control group. A common way to assign patients to treatment and control groups is by using a random process. This is the essence of a completely randomized experiment. So here's an example. Can chest pain be relieved by drilling holes in the heart? For more than a decade, surgeons have been using a laser procedure to drill holes in the heart. Many patients report a lasting and dramatic decrease in angina, which is chest pain symptoms. Is the relief due to the procedure, or is it a placebo effect? A recent research project at Lenox Hill Hospital in New York City provided some information about the issue by using a completely randomized experiment. The laser treatment was applied through a less invasive catheter laser process. A group of 298 volunteers with severe, untreatable chest pain were randomly assigned to get the laser or not. The patients were sedated but awake. They could hear the doctor discuss the laser process. Each patient thought he or she was receiving the treatment. The experimental design can be pictured as, so we have our patients with chest pain, and then these patients are randomly assigned to either group 1 or group 2. All right, so both groups thought that they were getting this treatment. They heard the doctors talk about it. They heard the sounds of the laser, etc., etc. However, one of them actually got the treatment, and then one of them didn't. So that was the experiment. And then the last step was to compare the pain relief. The laser patients did well, but shockingly, the placebo group showed more improvement in pain relief. The medical impacts of the study are still being investigated. It's difficult to control all the variables that might influence a response to a treatment. One way to control some of the variables is through blocking. A block is a group of individuals sharing some common features that might affect a treatment. In a randomized block experiment, individuals are first sorted into blocks, and then a random process is used to assign each individual in the block to one of the treatments. For good experimental design, you want to look for a control group. A control group that receives a dummy treatment, enabling the researchers to control for the placebo effect. In general, a control group is used to account for the influence of other known or unknown variables that may be an underlying cause of a change in response in the experimental group. Such variables are called lurking or confounding variables. Randomization is used to assign individuals to the treatment groups. This helps prevent bias in selecting members for each group. Replication of the experiment on the patients reduces the possibility that the differences in pain relief for the two groups occurred by chance alone. And then lastly, many experiments are also double-blind. This means that neither the individuals in the study nor the observers know which subjects are receiving the treatment. They help control for subtle biases that the doctor might pass on to a patient. Which technique for gathering data, so either sampling, experiment, simulation, or census, do you think might be most appropriate for the following studies? So if we do a study on the effect of stopping the cooling process of a nuclear reactor, well, this sounds a little dangerous. So the gathering data technique we will use is simulation, all right? And the reason why is because we don't want to risk a nuclear meltdown. Next, what if we study the amount of time college students taking a full course load spend exercising each week in the student recreation center? Sampling. We could take a random sample of full-time students and survey them in regarding the time that they spent exercising each week. Next, what if we do a study of the effect on bone mass of a calcium supplement given to young girls? Experimentation. So this is where we would want to give our sample, divide it, and give one group the supplement and one the placebo. Lastly, if we study the credit hour load of each student enrolled at a college and the end of the drop add period, we could use a census. This way, we could obtain every bit of information for each student. Take a second and read pages 26 through 29. A common means to get their data about some people is to ask them questions. This process is the essence of surveying. Sometimes the possible responses are simply a yes or a no. Other times, the respondents choose a number on a scale that represents their feelings from, say, strongly disagree to strongly agree. Such a scale is called a Likert scale. Here's an example of it. In the case of an open-ended discussion-type response, the researcher must determine a way to convert the response into a category or number. However, a number of issues can arise when using a survey. So here are some potential pitfalls of a survey. Non-response. So individuals cannot be contacted or refuse to participate. They can, and this can result in undercoverage of a population. Truthfulness of response. Respondents may lie intentionally or inadvertently. Faulty recall. Respondents may not accurately remember when or whether an event took place. Hidden bias. Questions may be worded in a way to elicit a specific response. Order of questions might lead to a biased response, or the Likert scale may force responses that don't correctly reflect actual feelings. Then we have vague wording. Words like often, seldom, and occasionally mean different things to different people. We have interviewer influence. Factors such as tone, body language, dress, gender, authority, and ethnicity of the interviewer might influence different responses. And lastly, voluntary response. Individuals with strong feelings about a subject are more likely to respond than others. Sometimes our goal is to understand the cause and effect relationships between two or more variables. Such studies can be complicated by lurking variables or confounding variables. A lurking variable is one for which no data has been collected, but that nevertheless has influence on other variables in the study. Two variables are confounded when the effects of one cannot be distinguished from the effects of the other. Confounding variables may be part of the study, or they may be outside lurking variables. We've briefly discussed three common techniques for gathering data: observational studies, experiments, and surveys. But which technique is best? The answer depends on the number of variables of interest and level of confidence needed regarding statements of relationships among the variables. Surveys may be the best choice for gathering information across a wide range of many variables. Many questions can be included in a survey. However, great care must be taken in the construction of the survey instrument and in the administration of the survey. Observational studies are the next most convenient technique for gathering information on many variables. And then lastly, experiments are the most stringent and restrictive data gathering technique. They can be time-consuming, expensive, and difficult to administer. In experiments, the goal is often to study the effects of changing only one variable at a time.